Probably. So welcome to my session. Thank you for coming. I know the competition is pretty good on the other side. So yeah, thank you for choosing this this room. So today I want to talk to you about the databases that we have here at CERN. So let me introduce myself. My name is Andrzej Nowicki. I'm originally from Poland, and I've been a database engineer here at CERN for a little bit more than 3 years now. And today I want to show you a little bit of how our setup is configured, how do we handle our databases. Before I continue, can I have just one question? I don't see the preview of the slides, so if you could have a look. Thank you. I know the presentation, so it's not a big deal, but you know, it's easier if you know what you're presenting. So here is my contact info. If you want to reach me, feel free to send me an email or find me on LinkedIn or find me here during today or tomorrow. So I'm a part of the IT department at CERN. So we are around 600, 700 employees here working directly in the IT department. The department itself is hosting services that are used by other users in the organization. So we are hosting, for example, the mail infrastructure. We are hosting some of the services such as Elasticsearch or OpenSearch and other services that are used by other users in CERN. But this doesn't mean that only 700 people in CERN are doing IT. This is just like this decision on the structural level. This is just our department, but there are other departments that have developers that have, for example, this conference is organized by with the big support of the FABBC group. So this is in finance and business computing, which is not a part of IT, but they are doing their share of programming and IT stuff. So some of the services that we provide is, for example, the storage for the experimental needs. And last year, we've reached a huge mark. We have successfully provided enough storage, and we keep more than 1 million of terabytes. So that's 1 exabyte of data. You can see the growth over time of the solution that the IT department is providing. So as you can see, we have reached quite a significant number, if you ask me. And this is mostly experimental data. The data that's created by the experiments is not stored in the databases, but I decided it's good to show you that we are talking about quite a big scale of data that we handle. So how did the databases at CERN start? So in the year 82, Oracle was decided as a supplier for relational database software to be used at CERN, and it has grown over the years. Basically the offering from Oracle has also improved. So we right now have more than 100 databases with more than 11,000 users of said databases, like users and schemas. So that's a pretty big environment. We are using pretty much every single technology from Oracle there is. We are using clusters, we are using the data guard, so the replication technologies. We also used Golden Gate a little bit for the replication, as well as the OEM for monitoring. So pretty much everything there is. And we are also, it's not very frequent, but we are also user of the OCI, so the Oracle Cloud infrastructure. And as you can imagine, it's a pretty complex environment. I found in our archives the photo of the first page of the Oracle user guide from its 1981. This was Oracle version 2.3, so this is the first Oracle version that was installed at CERN, and now we are running 19C, and the current, let's say, release from Oracle is the one that you can install in your own data center is 19C. And obviously we don't only do Oracle, we also have an offering of alternatives, let's say. So we have our service, our internal users can request databases that are MySQL, Postgres, or Influx. And yeah, we have around 600 instances of MySQL offered as a as an internal solution for our users, 400 Postgres and 200 Influx databases. So this is an offering that we started in 2011. Because there is a need to have something that's cheaper than Oracle. We all know that Oracle licenses are pretty expensive. So our internal users were requesting something else from us. So this is why since 2011 we are supporting these databases, and we provide the backup, we provide the monitoring, the possibility to do clones and replicas for those databases, as well as some automation in terms of upgrades. But some of the database administrator tasks for the database on demand and it needs to be done by the users themselves. So it's like an inner offering that's maybe database. You can call it maybe database as a service. So in terms of the size of the environment, it's pretty big. So for the total size of the Oracle databases is around 5 petabytes of data. These are statistics from the storage size. So from the storage environment, so it's around 5 petabytes of data stored in Oracle databases, and around 150 terabytes of data in the alternatives, let's say. So MySQL, Postgres, and Influx. And on top of that, we also hold around 3 petabytes of backups. The 3 petabytes of backup is less than the 5 petabytes of total data size. This is because we are not, for example, doing backups of all of our dev and test environments. And for example, we also compress the backups. So this is why the size is significantly lower. So one of the first points that I want to talk about is user management. As you know, CERN is pretty big. You've probably seen some parts of it today. We, as CERN, we have almost 20,000 people collaborating with us. The people that collaborate with us, they can request accounts. They have their needs to manage accounts, to have access to data. So we need to have a way to manage the user accounts. So what we try to do is we try to keep our data in schemas that hold the objects like tables, views, and etc. And then each application or each person gets a read-write account or read-only account if they don't need the write access, and we provision them automatically. What we try to avoid to do is to have open schema accounts which hold the tables. When you share this type of data, this type of accounts, like you don't know who changed something. People share the passwords to the accounts. It's an absolute nightmare to manage, to debug in case of problems. But we have our fair share of problems with that. So this is an example from our production system where the same user is used by 45 different applications and users. So imagine somebody deleting some data from a table. You don't know who did it, from where. It's pretty hard to debug. So this is what we are trying always to do to make it right, to create accounts that are used only by one application. But what comes with the user management is also resource management. So since it's such a big community of our users, we need to make sure who's owner of which account, who's owner of which table, and who's responsible for making sure everything works. So for our users, we give them 2 options. Either the owner of a user account can be a particular person, and a person with, let's say, like only one person, but then they can also create a service owner which is tied to a group, which makes it easier. For example, if you have a bunch of people administering the same solution, it makes it easier to manage in case somebody goes on vacation or somebody leaves the team. It's easier to offload the responsibilities. The problem with the first type of the owners is that what do you do when you leave the organization? We have quite a big turnout, like with people coming and going. They are sometimes owners of hundreds of resources. So we have a system to track the ownership. In case somebody leaves, we have a procedure that either we ask the person to reassign the resource to somebody else before leaving, or it gets automatically reassigned to their supervisor. And this is how it looks, for example, for the Oracle accounts. So on the left-hand side, you can see the request to create a new database account. So you just need to provide the login, create the database that you want to have the account in, and some short description. And once it's approved, you will see the part on the right-hand side. So this is, for example, what you can do in our self-service portal, like unlock the account in case it gets locked, or you can change the quotas, change the passwords. So there is no need to involve the database team. If you simply forget your database password, you can do it by yourself. So this is how it looks for Oracle. And some of the other offerings that we have is, for example, Session Manager. So you can see which sessions are doing what in your database. And here you can see that we have multiple tabs for multiple options, like depending on your permissions, you can see only your sessions, or maybe you can see all of the sessions in the database. You can kill some of the processes in case there is somebody that has a lock on a table that you know that shouldn't be there. So this is also something that you can do as a user, and you don't have to involve the database administrators. So it's pretty useful for us as the database team, because a lot of people can solve their own problems by themselves, so it's faster for them, and it's not relying on us to fix, I don't know, like an application lock problem, so they can do it themselves. Another big point that we have, since we have like hundreds of databases, automation is a pretty big thing for our team, because if we didn't automate stuff, it would be pretty impossible to manage everything and to administer it. So we took a look at the stuff that we do quite often, and we decided to automate the most important parts. So for example, the patching of the databases, patching of the clusterware for Oracle, this is something that's automated. We often migrate the databases between different hardware. We provide new installations, new setup. So this is stuff like that we already have automated. And this is an example of a job that we have, so you can see that this is Oracle specific. I'm mostly an Oracle specialist, so this is why a lot of my examples are Oracle based. So you can see that this is a job. On the left hand side, you just provide the version that you want to update to. You provide the service, the cluster name, and then the job is running. So you can see that it's doing steps, and each step has their own recorded return code. You can see the time, how much it took. So by using that, we can change the version of the clusterware with no interruption, and it's something that we do without manual intervention. So you can just run the clusterware upgrade job and take a sip of your coffee, and 20 minutes later it's going to be done, hopefully with no interruption to our users. And yeah, the tool is pretty powerful. If something breaks, you can go into the log, you can see what failed and why it failed. So we are using Rundeck, but this is just one of the tools that are available on the market. I know that people are using different technologies, but this is just to show you how we decided to do our things. For the database on demand, so the MySQL, Postgres, and InfluxDB offering, the system looks a little bit different because this was integrated with the new resource portal. So the request for a new resource looks a little bit differently. So you just need to provide the category, whether the database that you want to create is production on test environment. You just need to provide the project and the type of the database, so whether you want to have MySQL, Postgres, or Influx. And you create the resource. When it gets approved, you get access again to the management portal. The management portal, this is on the left hand side, you can see the screenshot of how it looks like. So this is a list of the instances that I have access to. You can see their states, whether they are running, whether they are under maintenance, whether they are busy or stopped. You can see the type of the database, the versions, the host name where it's running, etc., etc. And on the right-hand side, you can see how it looks for this particular database. So you can find quite a lot of information here, like the owner, the person that you can contact in case of problems, the group that's the managers of this database, so people who have access to this to manage this database. There are some other options that I will talk about here. Yeah, so there are jobs you can submit. You can change the version of the, for example, MySQL or Postgres. You can upgrade it yourself. So you just submit a job and it's upgraded. Before the upgrade, we obviously suggest to our users that they should create a clone of their database and then test on the clone whether they can upgrade the database, whether their software is working correctly with the new version. So as you can see, this is like everything is visible. So I don't know if I'm as a DBA, I need to do some maintenance on a database. The client, internal client, will see the entry that, oh, I did this and this and that. And when you open the log entry, you can see that this was issued by this particular person. So you know who to contact in case of any issues. So the portal is also allowing our users to look into the logs of the database, so you can see the MySQL log or Postgres log, the standard log, but you don't need to log into the server, you don't need to do anything, it's just available in your browser. There is also a nice feature to auto-refresh, so you have the up-to-date information, what's happening in your database. The next tab here is a small file editor, so we allow our users to modify their configuration based on their needs. There are some stuff that we don't allow our users to modify, but up to a limit, they can, up to some point, they can change some of the parameters of their databases. So they can upload the changes themselves and they can restart themselves. So it's pretty much covering, let's say, 90% of the administration stuff for MySQL and Postgres. The backup and restore, so we take backups of our databases for our users. They can restore automatically themselves. They can do a point-in-time restore. They can also do creating a clone. So that's the next tab. So they can create a clone, and you can create a clone, and you can see that, oh, something is not working, so with my version of the software that I'm using, with this new version of the database, for example, so you can work on the clone, fix it, and then only then after you fix your issues, you can do it on production. So other offering that we do for the MySQL and Postgres and Influx users, we provide them with quite a lot of information in Grafana for the monitoring, and the possibility to do upgrades. So the version upgrade for MySQL or Postgres, it's pretty easy. You just click a button to upgrade, and then it's showing you a confirmation screen. And if you confirm, hopefully, 20 minutes later, it should work. And it's pretty widely used on internally. So there are many users. As you have seen, like, it's more than 1,000 databases. But to cover some of the examples of the systems that are relying on the database on-demand service is, for example, the Indico system. So some of you probably registered to this event using the Indico, at least the people from CERN. So this is a tool that we use to book rooms, meeting rooms, to organize conferences. We use it for our SSO, so single sign-on, 2FA system. We use it for Jira, for GitLab, for OpenStack. Also, our websites are relying on the DBOD. So it's pretty widely used all across CERN, and it's not only, let's say, the support stuff, the support of the laboratory itself, but it's also the experiments. So, for example, the file transfer system or the Atlas production and distribution analysis system is also relying on the database on demand. So the plan is to upgrade all the things. This is what you always want to do. You want to have the fresh versions, but there are some caveats. So if you have a very big environment like we do, sometimes we encounter weird issues. So one of the issues was one time a guy created a ticket with us, asking us that there is a problem with our Postgres instances in his database, because he has a unique index, but he has duplicate values in the unique index. And we were thinking that, come on, it's impossible. It's Postgres internals. It shouldn't happen. So by digging deeper, we noticed that his database instance was migrated between the Red Hat, I think 6, and it was migrated to Red Hat 9. And what was the issue was that the new version of Red Hat introduced new version of glibc, and the glibc comes with the new locale, and the new locale is changing the sorting order, and Postgres is relying on glibc library to sort the indexes. So we have found a case where this causes problems with the indexes. The broken indexes meant that we had indexes with duplicate values in unique indexes, something that should never happen in a database. So right now, we detect it for our users, and if it happens, if they are in this corner case, if this index, and only some of the indexes were affected, like very particular conditions needed to be met to have this kind of situation. So we have found that, we fix it for our users, so our users don't have to actively monitor against it. I've put in some links in the presentation if you want to read more about this case. I will share the presentation at the very end, so you can either take a photo now and I will share the link to this presentation. So I think it's pretty powerful for our users that they have the experience that we have, the expertise of our team, and they don't need to be DBAs themselves because we try to cover as much as we can for them. And I have another story to tell you. So imagine, this is a real case that happened in 2022. So the organization is always closing down because the LHC is not working at the end of the year. So between Christmas and New Year's, there is a 2-week period where our operations are very, very limited. So it was 2022, second to last working day, so the 20th of December, in the late afternoon. This is how our main website looked like. If you went into home.cern or cern.ch or home.cern, this is what you were seeing. So this is not normally what you can how our website looks like. So this was just a welcome screen with pretty default configuration. It's I see some smiles here because people know the case. So, people were thinking about, traveling back home for Christmas, and this happened. So obviously the team responsible for the web infrastructure noticed pretty soon. They fixed the nice outage information on the website, but we needed to investigate what happened. So the first thing that we noticed was that the web servers were in a weird state. They were serving empty pages, like some misconfiguration problem was the first idea that we had. So they reached to the database administrators and they asked us, hey, can you look into the databases because we have a problem with accessing this database that we use to host our main website. Well, the database was not there anymore. So what actually happened? So some of the orchestration tools that we use deployed some Q&A settings on production, which led to removal of some of the dependencies. As soon as another system noticed that the dependency is gone, this caused a cleanup using an API that we provide, so the database got deleted because it was no longer used. That's a big oops. And you don't want to do it the second to last working day of the year. So this is actually the case, and it took us several hours to restore our main website, and we learned from that, obviously. So we want to automate as much as possible, but you need to protect your critical infrastructure. For example, from automatic deletion, from some processes, cleanup jobs that do some kind of cleanup operations. So you can implement some kind of combination of rate limiting of your deletes, or delaying the deletes, or disabling the auto removal of some mission critical resources. And sometimes what happened was, for example, the resource management portal might give you an empty set of data. Then you can, if you have a system that's written like, oh, I don't have any resources, So there is an inconsistency between what I have running and what I have in my resource management. I should probably clean up those. Well, maybe it's not the best idea, because if your automation kills, I don't know, 100 databases at one time, you have 100 databases that you need to discover. So yeah, this is what happened, that our orchestration tools were removing some resources such as databases. So this is one of the interesting cases that we had in the last years. But there is more. You always need to consider corner cases. So for example, as I've presented to you before, we have a job to upgrade the databases. It's automating the upgrade process as much as possible. But what will happen if you try to upgrade one of your databases that you rely on in this process? So imagine we are using Rundeck. What happens if you try to upgrade the database that the Rundeck relies on? Well, it probably will not work, or there will be some kind of a corner case. So what we are always trying to do is try to automate as much as possible. But there are some corner cases where you might still need to do some manual work. Some manual work might be needed to do some kind of intervention. Another corner case that I can share with you is that if you use DNS names to configure your database replication, this is completely fine. This is pretty standard. Everybody is doing that. Nobody is relying on IP addresses, because this is what DNS is for, right? But what if your DNS service is relying on your database service? You have a circular dependency, and then if one of those two goes down, it might be a problem to start them up. So for this is a simple case. This is a simple. There is a simple solution. You just need to put the entries and the static IP addresses in the etc hosts in your server configuration. But there are many, many more cases of things like that that might happen. Yes. So another example. I'm good on time. So another thing that I want to present to you is a very, very powerful tool from Oracle, which is called database links. So database link allows you to access data from a different database using this particular feature. So here you can see that there is a simple application. It's using a middle tier connection pool, which is connected to the blue database. And then there is a database link between the blue and the red databases. So your application might be relying, without even knowing, on a different database. So what will happen if you shut down one of the databases that's involved? Imagine you have an application, it's connected to the blue database, and you do some maintenance work on the red database. You inform all of the users of the red database, but if you are not aware of the fact that there is some dependency between the blue and the red, it might cause you a problem. And this is something that also happened to us. So we had the application. The application was trying to access some data. The database was underneath the request from the application. It was connecting to the red database. The red database was not available. So what the application did, it retried the same query and again until it completely filled the connection pool. It reached the maximum size. Everything was waiting on the red database. We didn't know that there was such a dependency. So your application is down, and you didn't even know how it happened. Another case with the database link is that you can have an application that's doing some update on one table, and Oracle provides you a very nice feature of triggers. So you can create a trigger that will populate the changes to the other database. So imagine a situation like that. You have a change on the table T1 in the blue database. The trigger on this table is propagating this change to the table T2 in the red database. But there is another trigger, and this second trigger on the red database is replicating the data to the blue database, but it's the same row. And what will happen in case of this circular dependency? It will never finish because it's impossible. So the situation is locking your data in a way that it's really hard to debug, because it's completely two different systems on two different or maybe four different machines. It's really hard to debug, and your application is just stopped in processing because it's trying to update the data, but it will never finish because there is no it will never finish because the lock is there, so both of the triggers are in progress. So you need to make it stop. And another tool that we use to make this type of situation stop is we have a database links viewer. So since the database links are very powerful and it's very widely used here at CERN, we provide our users with the possibility to list the links that they have configured on their schemas and the objects that they might be accessing. And if one of the database links is misconfigured or there is a problem, we actively send an email to the users telling them, look, you have a database link that's probably pointing to nowhere, can you please clean it up? Or there is a database link that links to an account that's locked, so it will not work. So in order to know about those type of dependencies, we provide our users with tools like that to make them at least aware that it exists. Another interesting case that we had last year is, this is a very simplified scenario. So imagine there is a table. It's pretty simple. It only has one column with a definition of number. There is a view on this table. It selects the data from this table, and then there is the materialized view based on this view. The materialized view is, to put it simply, it's just a snapshot. So you just take a snapshot of whatever the contents of this view is. So far, so good. It's pretty standard. It exists in all of the most popular database systems. But what happens if you change the definition of the view? If you start to include the materialized view in this definition, you have a circular dependency. And for example, in Oracle, it will work. It will not return something that you would expect, because the second part of the union all will be simply empty, but this will work. This is a valid SQL statement. This is not a problem. If you just query the data, if you modify the data, this is fine. But as soon as you do a table modify to change the definition of the column, this will invalidate the view. And the invalidated view will invalidate the materialized view. So you start to propagate invalidated objects in your database. So normally when you have invalidated objects in your database, some of them, they will just be invalid and you will not be able to use them. There is a script, for example, in Oracle to recompile the objects, but it's not working because of the circular dependency. And it wouldn't be a problem if it was just one or those two objects that would be impacted. But this particular code, the UTL recomp, the one that fails with the cycle detected, this is used with your patching procedure. So as soon as you finish your procedure, this code is being running. So if you have a situation like that, good luck with your next patching session, because it will fail. The process will simply fail because of the circular dependencies, because the internal procedure will crash. So we are monitoring against that. There is a tool there is a script written by Oracle, so you can use this query to monitor. But again, this is something that you wouldn't know because it shouldn't really happen, so it's not in the documents. You have to really look for it to find something like that. And since I covered patching, what we are trying to do, we try to run the fresh versions. It's very hard to be always up to date with all of the releases that are happening for MySQL, for Postgres, for Influx, for Oracle. Oracle itself is releasing patches every quarter, and if you have 100 databases, that's quite a lot of work, even if you have that automated, because you need to announce it to the user, you need to agree on a date when it will happen. So what we are trying to do, so this is, for example, a list of recommendations that we follow for Oracle, but there are other sources for MySQL, for Postgres. A lot of people that are in the database world, in the database community, they share their cases. They show off the problems that they had. So it's always a good idea to follow other people to know what you can expect. Okay, so the next point on my list is backups. So as you know, we provide the backup solutions for our users automatically. And what we do, we use a combination of both snapshots and backups. And as you know, snapshots are not backup, so this is why you need to have a combination of two. And this is pretty much the same thing that all of the big players in the database as a service providers are doing. So the snapshot will let you recover some data fast in case you, for example, by accident you drop a table or you delete some data, but they will not help you in case if your storage crashes or if your DBA is angry at the organization, they try to remove some data. So one of the things that we are actively looking into right now is to have immutable backups using the cloud providers, because the biggest cloud providers are providing right now the solution to keep the write once, read multiple times backups. So for backups, remember, snapshots are not backup. They are not good enough. This is pretty standard. Everybody knows that there's this rule of keeping multiple copies in different locations, etc., etc. But there are many cases of people that don't actually follow that rule. So I have mentioned in my title that we have quite big databases for our experiments. Some of the databases that we use for the biggest experiments at CERN, they are more than 30 terabytes in terms of size. So for Oracle, they use partitioning quite a lot. There are multiple options for partitioning from Oracle. Just to give you some let's say starting point for very large databases. There is a really nice guide from Oracle about the very large databases and partitioning. So if you're interested in that, please follow that, because this is a very powerful tool which can help a lot if you have a big data size. What we also have, since it's very often that you have to copy some amounts of data or vast amounts of data. For example, for Oracle, we provide a data pump. Oracle provides a data pump tool, and we providing an abstraction layer for it. So by using the internal tooling from Oracle and automating it on our side, the copying of the data between two different databases for our users is as simple as one PL/SQL statement. So it's as simple as executing one PL/SQL procedure, where they can provide the destination name, include tables with particular names, or exclude some objects. So it's pretty configurable. There are lots of customizations that they can use to automate and make their flows automatical. So I know of people that they use this procedure, for example, in their deployment process, to make a copy of the data before the deployment, for example, or to copy some of the data between the production or between the dev and test. And another option for migrating big amounts of data is to use replication and cloning procedures. So and this is an actual photo from the data center that we have here at Maran's site. So we are using the physical standby databases, so our replicas of the data, to create clones. And by utilizing the thin clones, so the storage clones, we can make a clone of a 10 terabyte database in 4 minutes, which is pretty impressive. If you need to test something, you just go into our automation, you click 2 buttons, and then 10 minutes later you have a database that's set up, ready for you to play around with your SQL statements that you want to check something. So it's a pretty powerful technology. Obviously, you need to have the storage capabilities to do it, but it works for us, and we are pretty happy with that. As a reference, this is how you can do it with Oracle. So if you want to take a photo of it, these are the documentation that we based our solution on. So another stuff, like some more internal stuff that we are doing for our needs within our team, is centralized logging. So it's always a good idea to have your logs in one central place. So we are collecting the backup logs, the database logs, audit logs in one place. And then we can search for particular errors. We can filter by database name. We can filter by the issue that we encountered, by the problem, and we can also do monitoring on that. So that's a pretty powerful tool as well. Since I covered alerting, one of the things that we don't do really well is how we have our monitoring system alerting configured. So this is an actual screenshot from my mailbox. So for Oracle itself, over the 30 days, we get around 2,000 emails. And you know what happens when you get 2,000 emails in 1 month? You just delete them all. So this is what you shouldn't be doing in terms of the monitoring. And here I think it's a bit ahead of time. So I would like to thank you for your attention. And I think if you have any questions, feel free to ask them now, because I wanted to finish early just to give you the opportunity to discuss a little bit more if you have any questions. Yeah, and by the way, the QR code leads to my website, and the slides are available there. I did the QR code because I know the spelling of my name it's an absolute nightmare for people that are not Polish. So. No questions?
Are you monitoring the table spaces and stuff also with your cloud?
So for table spaces, sizes, and all that, we are using Oracle OEM in terms of Oracle. So the monitoring comes from there. But for, I think, 90% of those, we have the big file table spaces, so they grow automatically. There are some limitations on our side, so we have monitoring of the quotas. So the table space can grow automatically, but we just set up quotas that, for example, you have 100 gigabytes to be used. If you reach, I think, 80%, you will get an email that, look, there is something going on with the schema that you own. It's growing, so we inform our users that you are reaching to the 80%. Is everything okay with your application? Is that something that you planned to do, or it's an application gone wrong? And sometimes it happens that it's a real use case and it's valid that the table space grows so massively. Sometimes it's a misconfiguration, so yeah, it's like 50-50, I would say. Yep. So for the applications, it's what we are doing is we keep the passwords and we have like secrets management systems. So we are not doing anything like for the applications to connect to the database. We are just using passwords that we store in the secret vault. Somebody else had a question? Yeah. So we would like to actively monitor that, but to be honest, it's impossible with this number of databases. And what we try to do is, for example, like at least for Oracle part, let's say, we split our team into, let's say, into groups, and the single point of contacts for each part of the CERN. So for example, I am responsible for handling the administrative databases. So I have in my responsibilities, I don't know, like 12 or 20 databases. And then when I have the time, I log into the database and I see what is the load on those databases. So it's like not automated, but from time to time we log in to see if there are any let's say, unexpected situations. We have an automated monitoring. So if something went completely wrong and the load on the database server would be, I don't know, 20 on a machine that's 8 cores, then we would be informed about that. But it's impossible on that scale to do like proactive monitoring that would alert us of a case before it actually happened, because before it happened. And it's similar with the DBOD. So in case of problems, our users can reach us easily. They just send an email or create a ticket, and we will help them. But it's really hard to do proactively. Yep. Sorry?
On your Elastic Stack, for example, do you have latency issues? And how do you solve
So
it?
I think that I'm not an expert in the Elastic, but I think that the cluster that we use for Elastic it's pretty big, and it's also partitioned vertically. So it's like depending on the let's say it's split by groups of users, let's say. So I don't know, our internal needs, it's a separate cluster. There is a separate cluster for the needs of the administrative department. There is a separate cluster for experimental. Yep.
Of course, having so many databases and they are so big, it also has a cost. Is it your department that will pay for it, or will you send the bill to the owner of the tables that pay it?
That's a very interesting question, and there is no easy solution to this problem. The problem of costing in the database is that there are multiple components that you need to take into account when you calculate the cost. So the cost of the storage, the cost of the license, the cost of the machines, and taking that all into account, it's hard to actually predict the total cost of ownership, because how do you calculate if, I don't know, you have a small database but a very heavy load on a small set of data, like, I don't know, like hundreds of transactions on a data set that's 100 megabytes in size. And then you can have a huge database, but it's not very CPU active. So this is a problem that, like the internal budgeting, we had several aims and attempts to calculate it for our users, and we don't have a dashboard that says, oh, this instance costs you this amount of money. We just noticed that for our biggest users, we know, for example, that like this experiment have, I don't know, like 200 petabytes of data in the storage. So they pay for the storage, not even the database, but the storage, and then you have 20 terabytes out of our service of, like, 1.5 petabyte of databases. So we calculated, but it's a very rough figure. It's just to give you an estimate and to give the experiments an estimate that, oh, this is the cost of the database service that you're using. So it's a very ballpark figure. It's not concrete. Any other question? Yep.
On the side of how many databases and like real hardware, and if you have a database, how many times do you grow it?
Okay, so it depends. The number of replicas, it depends on let's say, how important this database is. So for example, for the test and dev, we only keep one copy of the data. The idea is, in case it fails, you can always recreate it from scratch, or you can create it from production. For our most important mission-critical databases is, for example, 3 copies. So there are 2 copies in the one data center, and the idea is to have another copy in a different part of the data center, for example. Okay, I think I've run out of time. So thank you all for coming here, and if you have questions, I will be here or around at the coffee. So yeah, feel free to come up to me and ask me questions. Thank you.